Good evening, my warriors. Welcome to the second session of Gauss's Law. Last session, we have seen what is flux and how to use that flux in the Gauss's Law. We have seen what Gauss's Law is, and today we are going to derive the field due to different geometries using Gauss's Law. So all this with me, Shreyas, your master teacher for physics at Vedantu, going live. Hello, my warriors. How are you? Hello, Bhargav, Shreyas, Priyanka, Nancy, Shreya, Somek, Munna, Bhai, Yalini, Abhishek, Minion, Arti. Hello, everyone. How is everyone? Hello, PL. Hi, Srinu. Welcome aboard. Hi, Kushali. Good evening. This is your captain. This is your Thalaiva. This is your boss. Welcome aboard. And guys, I have been training a lot of kids for the past decade, and many of my kids are now in IITs, and that's why I'm here on YouTube to spread the joy of learning. So I have produced a lot of ranks. In fact, I like to boast about it because I'm proud about it, and many of my students have secured 2-digit All India ranks, and I really hope to bring in a change in all of you. So if you want to know more about me, do not forget to follow me on my Instagram handle. That's Shreyas_Vedantu. Yes, Nancy, new look. Okay, yes. How is everyone? Okay, let's see. Yep, Prakash, hairstyle OP. Thank you, guys. Yep, hair shed. Yeah, because guys, there is going to be a lockdown in Karnataka, and I thought, I'm not going to probably cut my hair for a long time. So better to get it styled for some time, trying something new. All right. So if you like my new look, do not forget to smash that like button down there. All right, if you like my new look, go smash that like button, and if you're new to this channel, do not forget to hit the subscribe button so that you do not miss any of the lectures. Munnabai, who said I'm 28? I'm not even 28. Hello, monkey, welcome aboard. Okay. Oh my god, why did you get blocked? Okay, Tamil epic comments and FC Vedantu fan club, don't worry. I'm going to go back later on and I'm going to unblock it. Don't worry about it. Okay. Oh my god, Abhishek, I'll definitely come to you. If you come down to Bangalore, I'll get my hairstyle from you. Okay, don't worry about it. And you should do it for free of cost. It's okay, I'll pay you back in kindness. Okay. So how old am I? I'll answer that in Coffee with Shreyas session. That's a standard question. In every casual talk that I have, sir, what's your age? Okay, that's a mystery. Sir is 16. Yes, Sir Raju said it. Yes, guys, I'm 16. Okay, hi Somek, how are you? And guys, those of you who haven't still changed your display pictures, the only way you will get noticed easily is when you have that Vedantu display picture on you. And many of the warriors out here like Munnabai, Yalini, Priyanka, Monkey D. Luffy, Mininarthi, Harshil, all of the warriors out here have already changed their display pictures. Go ahead, change the display picture with the link in the description box below. And I'm so glad that we have grown as a family. Now we are more than 30k subscribers, and I really hope with your continued love and support we are going to grow even bigger. And this is a new digital era. This is like the era of revolution, like how mobile phone transformed our lifestyle, how computers have transformed our lifestyle 30 years back, how vehicles transformed our lifestyle 100 years back. Same way, the digital education is going to revolutionize the way you guys learn sitting at home, and it's for the better. See, for last thousands of years we have been trained to learn from the blackboard, and this is a big change in the human history where you are suddenly going to learn sitting at home with new tools, quizzes, data analysis, machine learning, artificial intelligence running all in the background. And that is what Vedantu gives you with our 20 patents, guys. There are lots of patents in our platform which enable us to collect a lot of data points to help our students, analyze their mistakes and improve on their performance. So guys, believe me, even if you have missed few classes, it's okay. You can join in. It's better late than never. And join in this revolution, because this is going to create a big change in your life. No matter where you are, no matter how you are, no matter when you are starting, now is the right time to start. So Even if you have some backlogs, it's okay. Start with these live classes and you can cover up your backlogs using Replace. And I'll tell you more about our Pro subscription, which is a very amazing model, just like you have Netflix for watching movies and episodes and series, where you don't have to pay individually. We have an amazing plan for all of you to get rid of all the problems that you face, like I don't get the teacher of my choice, I don't get the language of my choice, I want to prepare for KVPY boards, JEE, NEET together, I want to prepare for other exams like Olympiads, I want notes digital, I don't want to waste time writing it, so I want test series, I want analysis, reports, all these things are there in the Pro subscription plan. The link is there in the description box below. Alright, so let's begin with our first question. I'll tell you more about Pro subscription towards the end of the class. Here's the first question, just to refresh your memory and see how much you remember from the last lecture. And in case you're joining in new, it's okay. Hello, Chitte Lashikala Reddy. My God, Chitti Shkala Reddy. If you have a short name, please let me know. Yes. Tamil epic comments, don't worry, I'm going to unblock you. Hi, Frederick. Okay, welcome aboard. Harshal, I'm very good. I hope you two are nice. Monkey और Kirito already said A. और अच्छी पीन हो तो उत्तराखंड आ जाना, मैं खुद बना के पिलाऊंगा. Oh my God, Shreyas, I would definitely love to come to Uttarakhand. I'll definitely show you the homework answer. So Abhishek, if it's a bridge course, I will show the answer of the bridge course in the bridge course. If it's a Pathfinder series, I will show the answer of the Pathfinder in the Pathfinder series. Okay. Hello. Yes. Somik, change the picture. Which picture? No, I'm not a picture. I'm a video. This is me. Okay. Okay. Yes, Frederick. It's a new one. Yes, Harshal, I do live in Bangalore. All right. Let's see how many of you got the answer. Guys, a cylinder of radius r, length L is placed in an uniform electric field parallel to the axis of the cylinder. So the total flux from the surface of the cylinder is the total flux. Come on, think about it. Definitely, Munnaba, you're going to be an IITian, that too from Roorkee. I would definitely love to come and have some nice canteen food and tea out there. All right. So guys, guess what? Whatever passes inside goes outside. Net flux is actually zero. You can use Gauss's law also to solve this. Remember, net flux through a closed surface is the charge inside by epsilon naught. You can see that there is no charge inside. The charge inside is zero. So hence the net flux is also going to be zero. That's one way of looking at it using Gauss law. So this is using Gauss's law. Net flux is Q inside by epsilon naught. Another way of looking at it is, if you look at the lines entering in, whenever it enters inside, remember it is negative. Remember I have told you this sign convention, and whenever it comes out, if it comes out, then it is positive. The field lines are coming out. So net flux will be in plus out, which is going to be zero. Hence the answer is zero. Yup, that's correct. I hope this is clear. Yes, Sudhir, don't worry. If you have any doubts, definitely let me know in the comment section below or ping me on my Instagram handle. I'll definitely help you out. Okay, just leave a comment. Now, before we go ahead, I would like to show you one more thing. All right. And that is, the last lecture, the response that, oh, this is a new guy. So this is somebody different. All right. I don't know him. And in the first lecture of Gauss's law, I had asked you certain questions and a lot of you have answered it. Oh, thank you, Velugula. Thank you so much. Oh my God, one of the best video for this topic, says Mansi Pathak. Oh, I would love it. Okay. Pallavi says, okay, some question, and a lot of people asking a lot of questions. So you can see, guys, if you ask any question, I try and reply to all of them as much as possible. And some people have also replied to the homework answers out here. All right. Some of you have also asked some doubts out here, and I have replied to many of them. And some of you have also given the answers to the homework question. So guys, do not forget that at the end, I'll give you a homework question and you need to put it up in the comments, and any doubts that you have, definitely put it up. This guy out here is definitely going to answer all your doubts. All right. He's my twin brother. I am somebody else. He's my twin brother out there. He answers all your queries. Okay. So let's get going. Okay, cool. Okay, Kirito. Let's go ahead with the next question. Hi, Neha. Glad you are early All right, not too late. Okay, cool. That's Sir's alter ego. Ooh, Bhargav. Nice one. Okay, so next question coming up on your screen is this. Very beautiful question. Which of the following are correct regarding Gauss's law? Hint, more than one options are correct. More than one options are correct. Come on, think about it. Think about it. All right, which of the following are correct regarding Gauss's law? For those of you who have forgotten Gauss's law, let me write it down for you over here. Cyclic integral E vector dot the area vector is equal to Q in divided by epsilon naught. And remember, this term over here is net flux. Net flux. Come on, think about it and try to answer this question. What is the answer? Some of you are saying B and C, some of you are saying B and D. All right, come on. Should I try both NEET and JEE after 12th standard? Yes, Mala Mohan, you can try both, but both are different kinds of examinations in terms of subjects. Although physics and chemistry is common, but you will need a lot of time to study biology or maths together. So I would suggest make something as your priority and keep something else as your secondary exam. So focus on one exam is what I would say. Yes, Neha, punctual bachi. Very good, Neha. All right, Ankit, you're a little late. That's what I was wondering. Where are the hearts today? Okay, hello, Akriti. Welcome aboard. Okay. Okay, let's see. Some of you are saying only A. Some of you are saying AC, BC, B and C, B and D. Okay, B and D. Okay. Chalo, let's have a look. So guys, in the LHS of the field, okay, think about it. Think about it. In the LHS, the field is due to which charges? This is because of inside as well as outside charges. So remember this. If you have charges like this, positive, negative, positive, I don't know, and this is your Gaussian surface. Again, there is some positive charge here, some negative charge here. You write down the field over here. This field is not just because of the inside charges. This field at any point. See, Gaussian surface is an imaginary surface. You can choose anything that you would like. Field is always because of all the charges, no matter where they are, inside and outside. So it says only because of inside. Now that is wrong. That is wrong. This word is wrong. It's not because of inside. In fact, it is because of inside and outside charges. So in the LHS, the field is because of both the charges. Great. Okay. Now, the next thing is, in the LHS, the integral depends on the net charge enclosed. The integral value, what is the value of the integral? Net flux. What does it depend on? This whole LHS? Enclosed charge, inside charge. So it depends on the net charge enclosed, which is correct. Because the LHS is nothing but the net flux. So that's why that is correct answer. Beautiful. Next one. Okay, if the charges enclosed move, then the value of the integral changes. Now that is wrong, because even if this charge moves somewhere over here, understand the RHS will remain the same. This RHS won't change. If this moves, RHS will be the same as long as the charges inside are inside only. So if these charges move around, if this charge goes somewhere over here, if this charge goes somewhere over here, net charge inside is still the same. So RHS will remain the same. So LHS should also remain the same. So the word changes is wrong. So C option is wrong. Hence B and D. Yep, B and D. So how many of you got it correct? Why am I only here to suffer, says Kirito. Oh my God. So that suffering is going to lead you. That suffering is going to lead you to paradise. Okay. Will you complete full 11th syllabus in bridge course before December? Daniel, bridge is a bridge from 10th to 11th. We will complete 11th standard syllabus in a separate series. So this is just like a bridge course, which is like a connecting course so that you understand all the basic concepts. All right, not this one. This is the Pathfinder series. So the bridge course will make sure you scale up. You are at this level, somebody is at this level, somebody is at that level, somebody is at this level. We want everybody to grow at that level, so that once you start the 11th standard portion, you start from the same thing and there is no ambiguity in that. All right, cool. Okay, so So I think Shimon sir, what he meant was we will have a complete 11th standard series. Okay, so we are going to have a complete 11th standard series. We'll not call it the bridge course. Okay, cool, great. Chalo, let's get going. So B and D are the correct answers. Beautiful guys, beautiful. Soumik already told. Interesting. Oh, Ankit, that's a good suggestion. Definitely. In fact, we have already told to keep Tattva on Amazon. Let's see how it works out, because with the pandemic-like situation, it's difficult to courier things. So things are getting worked out. Let me assure you on that. Now, let's try and use Gauss's law. Thank you, Neha, so much. Okay, so field due to infinitely long wire. This is an infinitely long wire. There is a point P at some distance. This wire is charged. How do you think the electric field will come out? How do you think, the electric field will come out? The field will come out everywhere. It's going to come out everywhere from those charges. And I think it will look something like this. Let me just show that to you. Okay, oops, yep. So if this is a wire which is charged infinitely long, the field will come out like this, the field will come out like this, the field will come out like this, and it will go there and there and there. Everywhere the field will go in all the possible directions. I hope you can visualize this. Now, I am standing at some distance and I want to know what is the field over there. First option is integration. Find the field due to each charge and integrate. That's a hell lot of a process. I wouldn't want that. In fact, I would want to use Gauss's law to simplify the problem. So let's see how do we do that. Remember, the first step in Gauss's law is to actually write Gauss's law. So write it down. E dot dA is equal to Qn divided by epsilon naught. Now, you need a Gaussian surface for this integral. You need a Gaussian surface for this integral. So choose a Gaussian surface, which is a closed surface, wisely. Now, I feel this given geometry probably is screaming and telling us, choose a cylindrical surface. Why? You will see. Imagine this. Okay, let's take this Gaussian surface. So this is point P. So I'm just taking a cylinder like this. Okay, so ignore that RHS, it's gone little bit asymmetric. Okay, so it's something like this. Now, let's see how is the field going to look like. The field at every point, all right, will look something like this. All right, there will be field coming out like that, and there will be field going like that. Okay, there will be field going in all the possible directions. That's how the field is going to look like. Don't you see? But there will be no field on this part and on the bottom circular base. There is no field over there. Is that clear? Yes. Baby Luffy, welcome aboard. Okay. Now, this gives us an idea. Acha. The term on the LHS, do not forget, this tells you net flux. Okay, this tells you the net flux. Flux through flat surface plus curved surface. So in fact, the LHS comprises of the net flux through all the surfaces. Now the best part is, two of the surfaces, the top one and the bottom one, is there flux or there is no flux? Think about it. Is there any flux or no flux? Think about it. Sakti, no, Sakti, I think you are colorblind. Noops. My hair is black. I don't know why you're saying it brown. I think just hit that computer a little bit. Just move it around. Just do this. Probably it might become black. Just try it out. No flux? Yes. So on the top and the bottom surface, yes, there is no flux. Correct. Okay, there is no flux. Yep. Now, that means if I split it up into flux from top plus flux from bottom plus flux from the curved surface is equal to Q in by epsilon naught. understand the first two terms are actually zero. The first two terms from the top and the bottom surface. The only flux is on that curved surface. The only flux is on that curved surface. So how much is that flux? Think about it. How much is that flux? Guys, flux is field into area. What is the best part about choosing the cylinder? Remember some time back I was telling you, this geometry is screaming and telling us choose a cylinder. The best part about choosing the cylinder is the field is same everywhere on the curved surface because you are at the same distance r. You are at the same distance r. So at that same distance, the field magnitude will be the same. Hence, it will be field multiplied by area. So it will be field multiplied by area. So that's flux. So the field is E. What is the curved surface area? What is the surface area of the curved part of the cylinder? It is circumference 2 pi r. 2 pi r is the circumference into length L. So 2 pi r into length L is the curved surface area. So L is basically the length or the height of the cylinder. Okay, r was the radius. Now LHS part is almost done. Now let's look at the RHS. Now there must be something else given to us. Yes, let's see what should be given to us. The thing that should be given to us is lambda. Now what is this lambda? Lambda is linear charge density. This is linear charge density. It tells me how many coulombs of charge is there per unit meter. If I take 1 meter, how many coulombs of charge is there? So lambda is charge per unit length. So the dimensions are coulomb per meter. So think about it. In this cylinder, in this Gaussian surface, how much is the enclosed charge? How much is the enclosed charge? Think about it. Akriti, I hope you are understanding. You are giving some worried look. I got scared. Okay. Muskan, you know me, I know you, I don't know you, maybe you know me. Okay, okay, think about it. Is it, can you give it to me in terms of lambda, L, R or something like that? Think about it. Lambda is coulomb per meter. So in this length, how many coulombs of charge is there? Okay, so Munna bhai, simple. Lambda is for per meter. Sigma is for per meter square. Rho is per meter cube. Remember that. Lambda is anything per meter. Sigma is anything per meter square. Rho is anything per meter cube. That's the that's the convention which is used. Okay, yes. So it will be, this Qin will be lambda into L. L. Why L? This is the length of the wire which is there inside that surface. That is the enclosed charge divided by epsilon naught. Think about it. Correct? Isn't this true? Lambda into L. Now the best part. What is the best part? See guys, L got cancelled. Beautiful. So E will be equal to, shift these dudes out there. So it will become 1 upon 2 pi epsilon naught. Alright, 2 pi epsilon naught. Lambda is still there and R is there downstairs. And that will become our formula. Done, done, done. Done, done, done. That's it. That's the field at a distance R. 1 upon 2 pi epsilon naught, lambda by R. And that's the answer, guys. So it is inversely proportional to R, directly proportional to lambda. And this is K by 2 because 1 upon 4 pi epsilon naught is that Coulomb's constant K. Done. Now, it should not be written as 2K, Munna bhai, it should be written as K by 2 because actually it was 1 upon 4 pi epsilon naught. Okay. Oh, sorry, my bad. So sorry, 2K, you're right, my bad. So sorry, it was supposed to be 2K. Yes, sorry. Yes, it will be basically, yeah. So when I write it in terms of K, so it will be 1 upon 4 pi epsilon naught. Okay, so this will be 1 upon 4 pi epsilon naught. Did I make a mistake? Let's just see. So sorry guys, this was 1 upon 4 pi epsilon naught. So this will be 1 by 2 times of 2 pi epsilon naught. So think about it. Alright. So when I write 1 upon 2 pi epsilon naught, it should be what? 2 goes on the top, right? 2 goes on the top. So it will be k into 2. Okay, yes, 2k times of that. So earlier by mistake I said k by 2, so it should have been 2k. Okay, I hope this is fine. Yep, clear? Yeah. So you should remember this formula. Now I'll tell you what is the irony of the situation. The irony of the situation is the Gauss's law has integral. Do you see that? Gauss's law has some integral, and often people think, oh my god, there is integral in this, so the problems are going to be tough. But that's exactly the irony. The irony is Gauss's law is used to avoid integration. Yes, do you see, we actually never did any kind of integration out here. We didn't do anything like that. So that's the exact purpose of Gauss's law, to avoid integration. So don't get scared by it. That's the best part. Exactly. Now that you know this formula, let me give you one interesting formula. So first of all, let me write it over here. Field due to infinite charged wire. I just figured it out, and that was 1 upon 2 pi epsilon naught. It is not 1 upon 4 pi, be careful, lambda divided by r. Okay, now that is if it is infinitely charged. But sometimes you are going to get finitely charged wire. I'll give you the formula for that. So when the wire is finite and these are the ends, this is the upper end, this is the lower end, the first thing you should do is draw a line from that point to the ends. Draw a line from that point to the ends and see what are the angles. This is alpha, this is beta. This is alpha, this is beta. Okay, these are the two angles, and this distance is r. Now think about it. If the wire is like this, imagine if the wire is like this, you are exactly at the center, then each charge will give field like this. Okay, each charge will give field like this, and because you are exactly at the center, these fields will have components x, y, etc. And only their x components will get added. Their y components will get cancelled. Do you guys agree with that? Yep. So guys, understand? I hope this is clear that, the y components will get cancelled out because of the symmetry. So there will be only x component. But for example, all right, you have a charged wire like this. Come on guys, concentrate everyone. And you are somewhere over here, asymmetric. Then what will happen? This charge will give field here, that charge will give field here, this charge will give field here, that charge will give field here. There will be more fields in this direction than in this direction. I hope you can see that. That means there will be one x component and there will be also some y component. I hope you can understand that. Yes, I hope this is clear. Yes, Alex, this is a class. Yep. All right. And there will be both kind of components. So remember, when you have alpha and beta, there will be both components unless and until alpha is equal to beta. So let's see what are those components. So first is EX component, the second one is EY component. So please understand, this was only for infinitely charged wire, but for finite wire, okay, this is the formula. I'm just writing it down over here. Remember this, EX is equal to, now instead of 2 pi it becomes 4 pi epsilon naught. Be careful, it becomes 4 pi and you have lambda divided by r as it is, but here you get a term sine alpha plus sine beta. Sine alpha plus sine beta, and the y component has the term same thing, 1 upon 4 pi epsilon naught lambda by r, and you have cos alpha minus cos beta. Now I know you will be like, no, I don't believe you. Probably I don't think this is correct. Hold on, I'm going to try and convince you that this formula is actually correct. Let's try this out. Imagine it was an infinite wire. So for infinite wire, guys, predict quickly and tell me what is the value of alpha and beta. For infinitely long wire, what is the value of alpha and beta? Come on, answer in the chat box. Hello everyone, welcome aboard, join in, and in case you are new to this channel, go hit the subscribe button down there, and if you are already subscribed, do not forget to smash that like button down there. Yep, 90 and 90, very good. 90 and 90. So if this is 90, this is 90, because both the angles will become like that. You are having an infinitely long wire. Alpha will be there, beta will be there. It's in 90 and 90. So what is sine 90? 1. What is sine 90? 1. What is 1 plus 1? 90, 90, 1, 1. What is 1 plus 1? It is 2. Now that 2 will cancel with this 4. And what will you get? You will get 2 pi epsilon naught. Isn't it the same formula? I hope now it's clear. I hope it is now clear. Yes, 90, 90 is 1, 1. So 1 plus 1 is 2. 2 and 4 gets cancelled. You will get back that original formula. So it proves, yes, this is correct. And one more thing, just to convince you even more, just to convince you. By mistake, alpha is equal to beta. Say, in a particular situation, alpha is equal to beta. If, for example, then shouldn't the y component be 0? Shouldn't the y component be 0? Because as many charges are there on the top, that many charges are there below. So there will be no resultant y component. There will be only x component. So guys, think about it. If you put alpha is equal to beta, doesn't y component actually become 0? So it makes sense, total sense. That's why there is a minus sign and not a plus sign out here. Excelente. Welcome Alex, welcome to the gang. You are now a warrior. So we call ourselves warriors. Yep, got it? Beautiful. So are you guys now ready for the question? Are you guys now ready for the question? Yep, let's get going to the question coming up on your screen. And here it is. Find the electric field due to semi-infinite wire having charge density lambda. Now I'll draw the wire for you and I'll also show you where you are. So this is a semi-infinite wire. This is going till infinity and you are over here. Okay, so guys, think about it. You are over here. What is the field due to a semi-infinite wire having lambda as their charge density? That's the charge density, linear charge density. Come on, this is semi-infinite wire. You're standing here. Okay. Yep. So guys, what do you think? What do you think? I think there will be two kinds of components. Be careful. Okay, before going ahead, let me just think what is the value of alpha and beta. Well, I think alpha is 90 degrees. Can you guess what is the value of beta? Can you guess what is the value of beta? It's 0. Yes, it's 0 because there is nothing down. So the second point is exactly over here. So that's why the value of beta is 0. Yep. So now try to figure out both the components. Ex, the value of Ex will be 1 upon 4 pi epsilon naught. Okay, lambda by r sine 90 plus sine 0. Okay, sine 90 is 1, sine 0 is 0. So this will become 1 plus 0. So nothing to cancel. So you are going to get lambda 4 pi epsilon naught r. So that's Ex. That's Ex, correct? Now, similarly, you can also find Ey, and Ey will be again 1 upon 4 pi epsilon naught lambda by r, and you have cos 90 minus cos 0. Cos 90 minus cos 0. So what are you going to get? You're going to get cos 90 is 0. This is 0, guys. Do not forget. Cos 90 is 0. Cos 0 is 1. So 0 minus 1? Minus 1. Now, don't worry about that minus sign because it just tells you the direction. So, although you might get minus lambda by 4 pi epsilon naught r, this minus sign signifies the field is not in the y direction, it's in the minus y direction. It's in the minus y direction. So basically there are two components out here. So one is Ex like this and the second one is Ey like that. Aren't both the components equal in magnitude? Aren't both the components equal in magnitude? So guys, what will be the resultant? The resultant will be root of ex square plus ey square, and you will get root 2 times of that. So it will be root 2 times lambda by 4 pi epsilon naught r. That's the answer. I hope this is clear. You can also write it in terms of k, because 1 upon 4 pi epsilon naught is nothing but k. But I hope you guys get it. What is epsilon? Epsilon is nothing. Epsilon naught. Okay, it's epsilon. Okay, so that is permittivity. That tells you how much is the field going to be permitted in any medium. So in different medium, the field becomes stronger or weaker. So that value parameter decides whether the field is going to become weaker and by how much amount. Okay. Okay, thank you, Alex. Glad you're staying back, and trust me, this is for all the sophomores, you can say, yeah, for all the 11th and 12th standard K-12 program, for all the competitive exams, Olympiads and all that. So that's the channel for all English, physics, we teach in English for physics, chemistry and maths. Okay, so let's do this next problem. Apsara, yeah, even Abhishek, even I heard the same thing. Oh, I relate with you so much. I heard Apsara. Like Apsara, oh my god. Why are people dreaming about Apsaras now? Okay, so field due to an infinite sheet. So what is the field due to an infinite sheet? Let's figure this out. So first of all, if you have a sheet which is charged like this is a sheet which is charged like this. Okay, how will the field because of that look like? Well, the field will come both ways. It will be coming like this, and it will be also going back like that. I hope you can visualize it. The field will be coming both ways, guys. Okay, and it will be going both ways like that. And I feel this field will be uniform field. When do you say the field is uniform? When do you say the field is uniform? You say that the field is uniform when the field lines are parallel, they do not diverge or they do not converge. Because then the strength, the density of the lines remains the same no matter where you go. So that's why this field is uniform. And now we introduce a term called as sigma. So what is sigma? Sigma is charge. How much charge is there per unit area? So charge per unit area. So remember, I was talking about this symbol some time back. So this is Coulomb per meter square. This is Coulomb per meter square. I hope this is clear. Hold on, Achyut. I know the formula. Many of you also know the formula, like Monkey and all the others. But we are interested to figure out how to get to that formula, because that's what is important. I know many of your coaching centers ignore those derivations. They just go to the formula and they're like, oh, okay, now start solving problems on Gauss's law. And then comes a problem and you don't know, sir, how to choose this Gaussian surface? I don't know. Because you guys have not been taught how to derive. So that's why I'm showing you all this. Watch it. Okay. Now, first thing, choose a Gaussian surface. Choose a Gaussian surface. This geometry is screaming and telling me to choose a geometry which is going to be cylinder. Okay, but if you want to choose a cylinder, how do you want to choose a cylinder? Vertical, horizontal, at an angle, what? How do you want to choose the cylinder? Yep. Okay, come on, think. What do you think the cylinder should be? Okay, vertical, horizontal. Should it be vertical like this? The axis should be vertical, or should it be horizontal? I feel, yes, it should be horizontal. Correcto. The reason for that, oh, I'll tell you what, you don't even need a cylinder. Yep. You can choose any geometry, guys. Some random geometry. This is not a cylinder. Somebody like distorted that cylinder. Okay, this is a distorted cylinder. It's okay. I mean, something like this. It pierces through it. It pierces through the sheet, inside out. The face is not circular. It could be any shape. So maybe it is something like this. So that is also permitted. This is also okay. I'll tell you why. Because on this flat face that you have, this flat face that you see, the field lines are anyways perpendicular and same everywhere. They are perpendicular and they are same everywhere. So it doesn't matter. Just doesn't matter. So just assume one thing though. Let's just say that this area that you see over here, let's say is A. This area is A. Let's now use Gauss's law and see what do we get. Let's start with it. Cyclic integral E vector dot dA is equal to Qn divided by epsilon naught. Let's start with this. No, nothing like that, Munna bhai. Who said cylinder is easy? No, that's wrong. Okay, that's wrong. Okay, yes, correct, Arman. Now let's see how to get to this. The left hand side again tells me net flux. Net flux. Now think and tell me, do these flat faces have flux or does the curved surface have flux? Think about it. Does this flat and that flat surface, it's behind, probably it is not seen. I can probably show a diagram something like this. It's there behind. Do these flat surfaces have flux or does the curved surface have flux? Come on, think about it. Come on, think about it. Yes, Vansh and Saroja, you can definitely ask the doubt if it is relevant to this session. Else, you can post it below in the description box, or sorry, in the comment section below. Yes, Sachut, it will definitely help. Yes, only the flat surfaces. So, I will say the flat surface is 0. Oh, sorry. Only the flat surface will have. The curved surface has no flux because the field lines are not piercing it. They are going parallel to it. They are not piercing through it. So what I'm going to do is the flux through the left plus the flux through the right will be equal to Qn by epsilon naught. How much charge do you think is there inside this cylinder? How much charge do you think is there inside this cylinder? I feel the charges are only there on that green part. See, if you look at it from sideways, this is that green part. This is that cylindrical object. Only this much part has charge. Nowhere else there is charge. It's empty. It's space, empty space. So how much charge do you think is there over there? Think about it. Use this formula, charge per unit area. So charge will be sigma into area. Charge inside will be sigma into area. So shouldn't this be sigma into that area of this part? How much area is there over here? Piercing. How much area is it piercing? Think about it. So it is A only. So I hope you understand, choosing a cylinder is not an obligation. You can choose any geometry. I don't know why people think, oh no, you should choose a cylinder. Oh no, you should choose a cuboid. Doesn't matter. Anything works out here. Sanjay, we will obviously start current electricity. Now let me complete Gauss's law first. Then I'll go to current electricity beta. Okay, just hold on. Correct. Divided by epsilon naught. Now, help me with this. Is the flux on the left side positive or negative? Come on, help me out. Is the flux passing through this surface positive or negative? Think about it. Come on, think about it. How does the opening surface area affect the amount of charge leaving the body? I'm not sure what you mean, Saroja Ahuja. Is the opening surface area. What do you mean by opening surface area? Yes, it's positive. Be careful. Be careful. It's positive. It's not negative. Remember, out. Field lines coming out is positive. Field lines going in is negative. Remember, I hope you guys remember. Some of you got confused. Coming out. So it's coming outside the surface. Outside that cylinder. So it's positive. And how much is it? It is E into area. That area is A. So E into area. Plus flux on the right side. On this side, is the flux negative or positive? On that side, is it positive or negative? Come on, think about it. Come on, think about it. Come on, guys, think about it. My God, Saroja, what are you even asking? Rectal area of the human body. My God, crazy terms. Take a chill pill. Aram se thoda discuss karte. Put up all your doubts in the comment section. I'll answer. Please explain in detail what is your bhavna. I'll definitely come up with the solution for you. Don't worry, Saroja. Okay. Positive again because it is again coming out. Correct. So it will be E into A again. So both are positive is equal to sigma A by epsilon naught. Correct. Now see guys what will happen. A and A goes and what will you get? 2E is equal to sigma by epsilon naught. Therefore, E is equal to sigma by 2 epsilon naught. That's the answer. That's the answer, guys. Yep. Sigma by 2 epsilon naught. Understood? Thank you, Bashik, for all the kisses. Love you too. Okay, chalo. I hope this is clear. Is that clear, everyone? All my warriors? Okay. Okay. Clear? Yeah, let's get going. Let's get going to the next one. Okay, so remember this formula. Remember this. This should be there in your notes. Let's see this question coming up on your screen. Okay, let's see if you can solve this question. X and Y are large surfaces. They are sheets close to each other. Each face has an area A. So the sheet area is big and it is A. And the charge, and given a change, not change guys, it's supposed to be charge Q. Y is given negative charge minus Q. Find the fields at point A, B and C as shown in the figure. Let's do this question. Now, first of all, think about it. On X, okay, so on X, this is about X, okay. What is the value of sigma? Sigma is charge by area. Charge given for X is Q. So it will be Q divided by area. Area is given to be A. Done. Similarly, for Y, the sheet Y, the sigma value again will be charge, but it is negative. I understand. I will take care of the directions later on. Don't worry about it. And Q by A. Okay, this is also done. This is only the magnitude. I understand there is a negative charge. Don't worry about it. This is just the magnitude of it. Don't worry. Okay. Now, let's do one thing. On X, there is positive charge. On X, there is positive charge. So the field will be outwards, something like this. The field, correct, will go like this on both the sides, correct? And on the Y sheet, on the Y plate or the sheet, the charge is negative. So the field will be attractive. It will be inwards. It will be inwards. So guys, think about it. All right. It will be something like that. It will be something like this. I hope this is clear. Yep. This is how it will be. Now let's think about it. If you are at point A, okay, then will the field, the green one and the red one, will they add or will they subtract? Will they add or will it subtract? Vibhor, nobody knows when the JEE Mains will happen or will it be postponed. The chances are it could get postponed, it could not get postponed, we do not know. So we do not spread rumors. So we have to be prepared for the upcoming JEE Mains. We are going to prepare as if the mains is going to be on May end. If it gets postponed, we'll change our strategies again. Yes, they will cancel, correct. So at A, the field due to X and the field due to Y cancel, and hence the net field at point A is 0. Correcto. Beautiful. Now at point B, think about it. Are the fields going to add or are they going to subtract at point B? Think about it. At point B, what do you think will happen? Come on, all my warriors, post all your thoughts in the chat box. Nobody is going to judge you. You should be very active. Come on, answer quickly. Is it going to add or is it going to subtract? Thank you, Mani. It's going to add, guys. Yes. So you can see both the fields are in the same direction. So definitely it will add. So EB will be addition of both of them. So it will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is sigma by epsilon naught. But what is sigma? It is Q by A, right? So it will be Q by A epsilon naught. I hope this is clear. Yes, it's going to double and it's going to be like that. Yep, correct. Got it? Now let's talk about C. For C, what do you think the field will do? Will the field add or subtract? Will the field add or subtract? I think again it will subtract because the green field is on the right side, the red field is on the left side. So I think the field at point C will be 0. So that's how you solve the problems. Is that clear? Beautiful. Excellent. Vibhor Krishnan, don't spam. Don't spam or else you'll get blocked. Already I have mentioned that the JEE Mains paper cannot be predicted when it will happen. I already mentioned that. Don't spam out here. Yeah, very good. Okay, let's get going. Cool. So that's the answer. We have just got it. Now let's look at this question. Beautiful question. I would request the admin to please ban Vibhor Krishna Mishra, please. Okay. So there is a large plane charge sheet having surface charge density this much coulomb meter per meter square, which lies in the XY plane. This is the XY plane. It lies in that big sheet. Find the flux due to the field through a circular area of this many centimeters inside that region where you know that circular object makes an angle 60 degrees with the z-axis. I hope this is clear. I hope this is clear. Okay. So when that circular area makes an angle 60 degrees with the z-axis, what is the flux through it? Now this looks like a difficult question, but trust me, it's not so difficult. Let's try to understand what is exactly happening. So if you look at that circular object, the area vector will be somewhat like this. This is the area vector, and that area vector makes an angle of 60 degrees with the z-axis. Okay, it is given. It makes a 60 degrees with the z-axis. Next, my sheet is over here. That is charged. Okay, my sheet is charged. So how do you think the field lines will go? How do you think the field lines will go? Will it go left, right? Will it go front, back? Will it go top, bottom? How do you think the field lines will go? Because of this sheet which is lying in the XY plane. Come on, think about it. The horizontal one. How will the field lines go? Will it go left, right, front, back, top, bottom? Think about it. Think about it. I feel it should go because this is a sheet in the horizontal plane. It will go on the top and at the bottom. Yep, top, bottom. Very good, Monkey Duffy. Very good, Nancy, Neha, Minyanarthi. Very good. It will go top, bottom. So here is what I will do. The field lines will go like this. This is how the field lines will go. Beautiful. Now this is the field. Do I know the value of the field? Yes. The value of the field is sigma by 2 epsilon naught. This is something which I know. Standard. Yes, this is something I know. And what is the value of flux? The value of flux is E A cos theta. So what is E? Sigma by 2 epsilon naught. Correct? What is area? Area is pi r square. And what is cos theta? It is nothing but cos of 60 degrees. Done, done, done. Now it becomes simple. Now it becomes simple. So just have to substitute all the values. But before doing that, I'll do a small change. Instead of writing 2 epsilon naught, so what I will do, I will write 4 pi epsilon naught. I'll write 4 pi epsilon naught. Okay. So I hope you understand why I'm doing that, because you know, I know the value of 1 upon 4 pi epsilon naught. So I'll have to multiply it with 2 pi. Because I divided by 2 pi, I multiply by 2 pi to conserve the equation. Now let's write down all the values. Value of sigma, 2 into 10 to the power minus 6. 1 upon 4 pi epsilon naught, the value is 9 into 10 to the power 9. Correct? Into pi, into radius is 1 centimeter. 1 centimeter is 10 to the power 2 minus 2 meters, the whole square. Okay, cos 60 is half into 2 pi. That's what I get. Okay, now cancel things. 2 gone. 2 into 9 is 18. You can see that. 2 into 9 is nothing but 18. And you have 10 to the power minus 6, 10 to the power 9 and 10 to the power minus 4. So 10 to the power minus 6 and 10 to the power minus 4 is 10 to the power minus 10. 10 to the power minus 10 and 10 to the power 9 is 10 to the power minus 1. Okay. And last thing, this pi and that pi will become pi square. Now I hope you remember the value of pi square is approximately 10. Approximately 10. So guys, think about it. 10 into 10 to the power minus 1. goes out, it will become 1 and it will become 18 units. Now what is the unit of flux? It's Newton per Coulomb into meter square. Newton meter square per Coulomb. That's the answer. Yep. I hope this is clear. Beautiful problem. This can come like an advanced question or a difficult mains question. Understand that. Yes, this is a very good question. Interesting. Let's get going to the next one. That's the answer, 18. Okay. Beautiful question. Let's see how many of you can do this. Come on guys, objective time. There is a charge sheet. There is a bob which is charged and it gets repelled because of this charge sheet. So there is a charged ball and it gets repelled because of the charge sheet and it maintains some kind of equilibrium. So guys, think about it. Think about it. What is this angle got to do with the charge density? How are they related? Tan theta, cot theta, sin theta, cos theta. Well, come on guys. Meanwhile, I'll start solving. First of all, the charge sheet will give field. The field will look something like this. The field will look something like this. And what is the value of the field? It is sigma by 2 epsilon naught. Correct? The field value will be sigma by 2 epsilon naught. Next, on this bob, there will be forces like this. Tension, weight, and there will be electric force. How will the electric force be? Electric force will be like that. What is the value of the electric force? Charge into field. Charge into field is electric force. Remember that. And if this is theta, I believe this is also theta. Now what do you do next? Some of you are saying cos, some of you are saying something else. What do you guys say? What do you guys say? Come on, think. What should you do next? What should you? Some of you are saying cos theta. Okay. Think again. No, it's not B. Think again. What we should do now? Use Newton's laws. Net force in X and net force in Y should cancel because it is in equilibrium. In equilibrium, net force must be 0. So, along the horizontal direction, what is it? QE force. Alright, QE force will be cancelled by tension's component. Tension has two components. In the X direction, what is the component? T sine theta. I hope you can see that. T sine theta. And in the vertical direction, what is the components? Oh, it is the weight which is down, which will be balanced by T cos theta. I hope you can see that. Now divide the two. Yes, divide the two. So the moment you divide the two, you will get QE by W is equal to T cancels, you will get tan theta. But hold on, what is E? Is sigma by 2 epsilon naught. So Q by W, sigma by 2 epsilon naught will be tan theta. So what is sigma proportional to? It is proportional to tan theta. I hope this is clear. Is that understood? Yes, got it? Oops. That's the answer, guys. Yep, tan theta. These kind of questions do come in mains exam. Understood? Clear-o? Amazing-o? Shall we go ahead? Okay, let's get going. Cool. That's the answer. Now, before we go ahead, all right, how about this question? Yep. How about this question? Okay. So, this is very interesting question. The surface charge density on copper sphere is sigma. So, the intensity of the field on its surface will be. Think about it. How about it? What is the answer? The surface charge density on a copper sphere is sigma. So what is the field on its surface? Well, let's do this question. First of all, the field will come out like this, like that. And what is the field value? What is the field value? It's like a point charge. It's like a point charge giving field, right? Isn't it like a point charge giving out field? What is the field due to point charge? 1 upon 4 pi epsilon naught, correct? The charge divided by r square. Isn't that true? Because of a point charge, this is what the field is. Now think guys, if that's the answer, okay, so the intensity of the electric field. So intensity of electric field means basically E. So the value of E can be written down in a very beautiful manner. Just rearrange the term. It will look like this. Q divided by 4 pi r square. So I'm just rearranging it, okay, into 1 by epsilon naught. Just rearrange. Now, what do you think this term is? What do you think this term is? Come on, answer in the chat box. What do you think? What do you think the answer is? What do you think the answer is? What is this? What is this term called? Q by 4 pi r square. Come on, think. Oh my God, what happened, Ankit? Are you sad for some reason? Don't worry, Ankit, I'm always there. And if you feel demotivated, etc., please get in touch with me on my Instagram handle. Okay, we are always there for you. Yes, so the answer is sigma. Correct. It's charge. This is charge. And what is this? This is area. So that is sigma by epsilon naught. And that's the answer. Where is it? Yep, there it is. That's the answer. Option D. Oops. Option D, guys. Option D. Sigma by epsilon naught. Very good. Beautiful. Interesting. Let's get going. Now, before we go ahead, let me tell you, I am right now teaching in many micro courses. You'll find my micro courses in the pro subscription. Things like H.C. Verma discussion, Erudov question solving. Also, you will find me in all the derivations of the 11th standard, and you will also find me in numerical problems. So chapter wise numerical problems I have taken and just conducted a course on that. Not just me, many teachers are there in many micro courses. The advantage of micro courses is that even if you're a 12th standard student, you can attend, you can join, enroll for free all the 11th standard micro courses as well, and you can attend these classes as if you are studying there for a long-term batch. So whatever backlogs you have, you can clear it out using these micro courses. And if you are already thorough with your concepts, then you can scale up, you can grade up, all right, using the advanced micro courses. So do not forget to check it out. All these micro courses are there in our pro subscription, and also the entire PDF of today's lecture which I'm conducting is going to be uploaded on the Telegram group. So if you're not a part of Telegram group, do not forget to join it. Now let's get going to the next part. This is a shell. Now only two geometries are remaining, shell and solid sphere. Are you guys game? Shall we go ahead? How is your Josh, guys? Let me know. Yep, this is very important. This is very important. Yes, Abhishek, very true. This is the only platform as of now I know which has micro courses, and I mean that's really genius work. I'll tell you, like you said, because you can revise all the 11th standard backlogs. There are advanced courses. It's modular, perfectly modular. You can design your own path. You can choose, okay, I want to study this, I want to do that, I want to do this. Completely up to you. Yep, Josh is high. Yo, not low. Very good. Come on, let's do this. Let's do this, guys. So the field due to hollow conducting sphere inside. Okay, if you are inside, where are you? You are inside, and this is charged like this. This is charged like this. Guys, think about it. When you're inside, what is the field? We need to figure this out, right? So use Gauss's law again. Cyclic integral E dA is equal to Q in by epsilon naught. Now, what is this geometry screaming and telling us? Which object, which surface, how should our surface look like? How should our Gaussian surface look like? I think it's screaming and telling us choose a spherical Gaussian surface. This is my Gaussian surface, closed surface. Any closed surface is called as a Gaussian surface. So guys, think and tell me, what is the charge inside? How much is the charge inside? How much is the charge inside? Vivian Gaming, your Josh is low. Why, bacha? What happened? Problem in life? पेट में परेशानी? जुखाम? सर What is the problem? What is the problem? Vivian Gaming? Oh, Vivan Gaming, sorry. Yes, 0. Excellent. So 0 by epsilon naught. So guys, if RHS is 0, LHS will also be 0. So hence the field value will also be 0. Correct. So the field inside a shell is 0. I hope this is clear. Is it clear? Okay. So the field inside a shell is 0. Okay. Now next geometry. Same thing, but you're outside. Same thing, you're outside. Again do the same thing. Cyclic integral E dA is equal to Q in divided by epsilon naught. Where is the charge? The charge is over here. The charge is over here. So guys, think, how should you take the Gaussian surface? Again, it's screaming and telling us, take a sphere. This is my Gaussian surface. This is my Gaussian surface. What distance am I at? I am at a distance of r. This is distance r. So now be careful. Is the enclosed charge 0? Is the enclosed charge inside that blue surface 0? No, right? It is in fact Q. It is in fact Q. Hey, yesterday we had Modi ji, today we have Trump, tomorrow we will have Kim Jong-un, and then we will have, I don't know, Jinping, yes, Xi Jinping, the Chinese, yeah, the leader. Then we'll have, I don't know, who and all, Hitler maybe, all right. So guys, the charge enclosed is Q only divided by epsilon naught. Now for this, do you agree, because of this charge, the field everywhere, the value of the field everywhere will be the same? The value of E will be same everywhere. Do you guys agree with that? Look at that. The field everywhere will be the same. Now the field everywhere is the same. Won't this term come outside the integral? So if that term comes outside the integral, the only term which remains inside is integration of area. So this is basically the sum of all the areas. Sum of all the areas on that Gaussian surface. That's basically the area of the sphere. The area of the sphere. What is the area of the sphere, guys? What is the area of the sphere? 4 pi r square. So this will be Q by epsilon naught. So what will you get field as? What will you get the value of field as? You will get 1 upon 4 pi epsilon naught, 4 pi epsilon naught Q by r square. Standard, which is same as KQ by r square. Yep, that's the answer. Very good. Is that clear? Is that clear? So Lavkush Singh, all my classes will start at 7:30. Sometimes the classes start at 9 o'clock in the morning. So all the details get updated on our Telegram channel, which the link is there in the description box. So if you are a part of it, you'll get all the updates. Okay, very good. Let's get going ahead to the next question. Okay, next part, field due to a non-conducting solid sphere. Field due to a non-conducting solid sphere at an inside point. So now there is a small change. Understand this. This is a solid sphere. It's charged like this. Okay, it's charged like this. Okay, very interesting. Okay, so something like that. So there is charges everywhere. There is charges everywhere. It's not a shell. Be careful. Now, again, if you are inside, this is screaming and telling us, choose a spherical Gaussian surface. This is my Gaussian surface. This is my Gaussian surface. And at every point on that Gaussian surface, I don't know, let's just assume that there is some field. I don't know how much it is. Okay, let's just assume there is some field everywhere. Okay, now think about it. If I use Gauss's law again, there is going to be a small change. E dA, okay, Q in divided by epsilon naught. I feel Q in will not be 0. I feel Q in will not be 0. Yes, 0 will not be there. Correct. When it is uniformly charged throughout, the field inside will not be 0 because there is some charge inside that Gaussian surface. Now, how much is that charge? How much charge do you think is there in this much part? I think I should use this fact that, you know, charge per unit volume is constant throughout the sphere. Charge per unit volume everywhere is constant throughout the sphere. So think about it. What I should do. Oh, the charge in this much part, the blue part, okay, is Q in. What is the volume of that blue part? What is the volume of that blue part? 4 by 3 pi small r cube. Small r is basically this distance, this much distance. That's the charge per unit volume in this part. Now that is also equal to the total charge, which is Q, divided by the total volume of that sphere. How much will it be? 4 by 3 pi, but capital R cube. Do you see the difference? Capital R is the radius of the sphere. Small r is the radius of the Gaussian smaller sphere. So many things get cancelled, and guys, I think you are going to get Q in, because this 4 by 3 pi, this 4 by 3 pi gets cancelled. You are going to get Q in as Q divided by R cube, Q divided by R cube. That small r cube goes on the top, so it will be small r cube on the top, and epsilon naught is there as it is. Yes, you need to derive all of this, and you need to know the derivations. If you do not know the derivations, trust me, you cannot score in mains or advanced. Lot of teachers skip this. That's the saddest part of the coaching industry. I can tell you big names. They make students sit from morning till night. Many quota coaching institutes do not derive these formulas after paying lakhs of rupees. Yeah, and we are on YouTube conducting classes for free and deriving these formulas. I sometimes feel, am I a fool or what? Yeah, I sometimes get that feeling. Okay, but trust me, from my past decades of experience, I can tell you that I am right, because many of my students have not just cleared IITs. Forget getting even 2-digit All India ranks. Many of my students, after entering IITs, have scored 10 out of 10 pointers in bits in IITs and NITs. Yes, they are toppers. They are gold medalists. So my learnings have helped them not just for IIT exams, but also in the future. So that's why I tell students, you should know, understand each and everything. You should question why, how, where, why. Only then you will understand this. So that's why we do this. These quota people, these people who make students learn from morning till evening, make them sit there like sheep or donkeys, useless. They don't do all these things. Okay, now this value of E, what will happen? This value of E will come out. Why will this come out? Because this E value is constant everywhere. It's the same value. So E into, what is the surface area? What do you think is the surface area? What do you think is the surface area? The surface area is 4 pi r square. Yes, the surface area is 4 pi r square. Now see what and all will get cancelled. Okay, I think this r square and this r cube will get cancelled. You will have just one r, and you will be left with 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught q by r cube into small r. That's the answer. Yep, that's the answer. Very good. So this is very important. It is proportional to r. Remember that. It is proportional to r. Cool. Great. Now, when you are outside, you can again do the same thing, guys. Now the second part is very simple. When you are outside, if you again choose a big Gaussian surface, okay, and if you take this radius as r, believe me, when you again apply Gauss's law, E dA is equal to Q in divided by epsilon naught, this value comes out as Q only, because the enclosed charge is Q, and this will again come out as E multiplied by 4 pi r square, and you will get the value of E as Q divided by 4 pi epsilon naught r square. It basically behaves like a point charge. It behaves like a point charge. The value is same like a point charge or a charge shell when you are outside. Very, very important. Okay, so that's very simple. So no need to again repeat the same thing again and again. So try it out. Let's see whether you can do these 2 quick questions coming up on your screen. Get ready, guys. 2 quick questions coming up on your screen. Come on. Fast. Let's do this, because I know Shimon sir's class is going to start in 15 minutes. Let's do this quickly. Come on. The field due to uniformly charged sphere of radius r as a function of distance from the center. How do you think due to a uniformly charged sphere? Uniformly charged sphere, guys. This is the sphere and it is uniformly charged. There are charges inside as well. Come on, think about it. What is the field as a function of r going to be? Come on, think. Okay, B, D. Okay, so first of all, try and recollect the formula. When you are inside, the formula was K, Q, small r divided by R cube. And when you are outside, the formula was K, Q divided by R square. Correct? Do you see here, when you are inside, it is proportional to R, and when you are outside, it is inversely proportional to R square. So as long as you are inside, it is proportional to R. You can see that it is proportional to R. And when you are outside, it is inversely proportional to R square. So I think B option is the correct option. Correct. So it is a straight line and then it becomes a curved line. Correcto. B. Very good, Ankit. You made all the notes. Yep. B with love, says Akriti. Yep. Okay. How to decide if it is SNC, SC, HNC? What do you mean by that? Monkey, Dilafi? Yep. I hope this is clear. If you can explain what that SNC, SC, HNC, HC is. Sounds very complicated names. Okay, meanwhile, how about this next question? Which of the following graphs shows the variation of field strength with distance from the center of hollow conducting sphere? Come on, hollow conducting sphere. Hollow, guys. It's a hollow conducting sphere. Come on, think about it. What should be the answer? It's a hollow conducting sphere like this. So, what do you think the field variation will look like? Come on, quickly answer the question. Okay, Akriti says A with love again. Okay, a lot of you are saying A. Yup. So guys, recollect, the field inside is 0 for a shell and the field outside for a shell is KQ divided by R square. So you can see it should be 0, right? So you can clearly see in this part, all right, it is 0, and over here it is inversely proportional to R square. Correcto. That's why. Yep. That's why the answer is A. Yep. Something is different with me, says Astha Prajapat. Okay, I don't know what is different. Okay. Oops. Where are we? Yep. So those of you who also are interested. Oh, by the way, I should also give you my homework question. This is my homework question. My bad. This is a homework question. Yep. So please solve this homework question. Post the comments in the description box below. Very interesting question. This will brush up all your concepts and this will ascertain that you have understood today's class. So do not forget to solve it and post it in the comment section below. Okay. And remember guys, our courses are making a difference. I can prove that to you in 1 minute. Just look at this. This is our JEE Mains attempt. All right. And this is basically the number of students who scored above 90 percentile. This was 686. Now, those of you remember the JEE Mains first attempt, it was somewhere in hundreds. Look at the number of students who have cleared the second attempt. It has almost become few number of times, and that's only because they joined the crash course. So in the first attempt, many people had not joined the crash course. After the first attempt, they joined, and you can see the numbers have improved, in the second attempt. So, that's what I always tell. So these results where so many students get 100 percentile, these results which tell you one in two Vedantu students are clearing for the JEE Advanced examination. This ascertains, this should give you the confidence that we are actually on the right track. And that's why guys, I'm telling you, don't start your preparation at the end. Start your preparation right now in our pro subscription where I am teaching. Shimon sir is also there. Wazim sir is also there. We conduct a lot of micro courses. There are in fact many more better teachers than me, I would say that. And there is an option of English and Hindi batch. So I know most of you are interested in the English batch. I don't know any other coaching institute which does this. So guys, do not forget to check out the description box below. In that, you are getting this pro subscription for 35,999 for the next 1 year till your JEE Mains attempt, with revision, with JEE Mains preparation, with test series, with regular tests, analysis, notes, PDFs, assignments, hard copy of our Vedantu material, live classes, recorded classes, micro courses, everything included. But if you want doubt solving, then go with the classic version. You also get doubt solving on our mobile app where you can chat with our doubt experts and get your doubts resolved. That's where you come with the classic version. And if you want the plus version, where you also get a mentor, personal teacher, if you want a personal teacher dedicated for you, then you go with the plus version. So all the three options are available. Generally, students go with the classic or the plus version for 12 months. And you can see that if you go in our description, okay, box below, you will see the link for the pro subscription. Just click on it. You will get all the details. You can choose classic or pro or light, all right, whichever version you want. All the details regarding the syllabus, what is the schedule like, who are the teachers going to be, all right, all the details are mentioned over here. So I would suggest you guys to go inside the description box, hit the link and say buy complete course. Okay, buy the complete course, log in, use a email ID for registering in case you have not yet registered, and use my coupon code, which is SHHPRO. That will give you this discount, else you'll have to pay and shell out extra money. Thank you guys for being here, and I'm hoping to see many of you in our pro subscription. And if you have loved today's session, do not forget to smash that like button and do not forget to hit the subscribe button as well. Thank you guys for tuning in. Bye bye. Neha, Akriti, Baby Lafi, Abhishek, Himanshu, Arman, Kirito, Manoj. Thank you guys so much. Take care. See you guys again tomorrow for the next class of Pathfinder series. Till then, stay safe, stay at home, take care of your health. Hasta la vista. This was Shreyas here.